A deuterium beam irradiates nitrogen-14 to create oxygen-15. We have to derive an expression at the rate at which oxygen-15 is created. It's easier than it sounds. So let's say the rate of creation is dN by dt. R is produced per second, I think it said. Yep. And let's say it decays proportional to the amount of nuclei. Now this is just a first order ODE. You can put this in simple linear form. Recall, this is simple linear form. So we would just move this here. We get dN by dt plus lambda n equals R. Let me mention that R is positive because it adds to the rate, and lambda n is the decay rate, so it's negative because it takes away nuclei. Okay, so there's 1,000 ways we can solve this. I'm gonna do the integrating factor method, which is the easiest, I think. So we say E, the integral of P of x by dy. P of x in this case is just lambda, so we get e to the integral of lambda with respect to dt, which is just e lambda t. So we multiply the whole only e by the integrating factor, we get e lambda t dn by dt plus e lambda t lambda n equals r e lambda t. Now, if we look at the left-hand side, it might not be that obvious, but this is just equal to, by a product rule of this. When you differentiate that, find a derivative of that, and multiply by that, you get that. When you find a derivative of this, of the exponential, and multiply by that, you get that. Just have to spot that one. So it's equal to R e lambda t. Let's move this around. Get n e lambda t equals the integral with respect to dt. Integrate that. Get r over lambda plus some constant. Now, let's clean this up a bit. Let's get rid of these exponentials. We're going to get n equals r over lambda plus ce minus lambda t. Because dividing through by that is just the same as multiplying by that. Right, so let's apply the boundary conditions where n of 0 equals 0. Because no nuclei is created when the time hasn't started. So 0 equals r over lambda, and e to the 0 is just 1 plus c. So that's our constant. Sub that in, we get n equals r over lambda minus r over lambda c. Oh wait, e to the minus lambda, sorry. That's your answer. Easy.